We're going to start using square roots. So one of the things about solving quadratics with square roots is we need to know the perfect squares. So the perfect squares we need to know: 1 is 1, 2 is 4, 3 is 9, 4 is 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 400 for 220, and 625. Now, when we're simplifying square roots, a square root is like a house that a number is stuck in, and it can only go outside if it is a perfect square. So we need to split these into factors. So if we look at 18, that's square root of 9 times square root of 2. So this becomes 3 square roots of 2. So let's look at some more examples. Square root of 24. We always want to come up with the largest perfect square we can that fits. So 24 is 6 and 4. So square root of 6, I'm going to make that square root of 3, and square root of 2. Square root of 4 just becomes 2. Square root of 3 and 2 I can't break down anymore, so it just becomes 2 times the square root of 6, because we can have to combine back the 3 and the 2. 12 and 75. Square root of 12 times square root of 75. This means we can multiply 12 and 75. That'd be okay, but that might take some time. Instead, we're going to factor these. So with 12, I always make it square root of 4 and square root of 3. For 75, I'm going to make it square root of 25 and the square root of 3. So then what I do is square root of 4 becomes 2, square root of 25 becomes 5. Then if you have two of the same thing, boom, boom, it becomes 1 on the outside. So we have 2 times 5 times 3, which ends up giving us 30. Now, 3 times the square root of 98. So 98, I'm going to break that down into 2 and 49. I know 49 is a perfect square, which is 7. So we still have the square root of 2, and we still have the 3. We multiply regular numbers by regular numbers, square roots by square roots, or radicals by radicals. So we end up with 21 square roots of 2. This should all be reviewed from way back when. Square root of 32, I'm going to make this the square root of 16 and the square root of 2, so it easily simplifies to 4 square roots of 2. Like I said, we want to get the largest perfect square out of it. Here, 2 times square root of 4 times square root of 3, 2 times 2 times the square root of 3, and so it becomes 4 times the square root of 3. Square root of 6 times square root of 8. I break down the 6 to square root of 3 times square root of 2, and the 8 to square root of 2 times square root of 4. These two become 1, 4 becomes another 1, and square root of 3 we just have to leave, so we're going to end up with 4 times the square root of 3. So there's the first page. Now bear with me a second so I can get to the back of the page. So we have solving with square roots now. We want to get the squared part by itself on one side of the equal sign. Take the square root of both sides, leaving one side without the square. The answer will give you a plus and a minus, because if you think about it, 6 times 6 is 36, and this negative 6 times negative 6 is also 36. So we need to take into account both. So if we look at this first one, x plus 1 squared plus 2, we want to get the perfect square part by itself. So we have x, and we're going to subtract 2. X plus 1 squared equals 18. Then we're going to take the square root of both. When I do that, I'm left with x plus 1 is plus or minus the square root of 18. Well, 18 breaks down into 9 and 2. The square root of 9 is 3, and then we have the square root of 2. And then the final step, we subtract 1. So x equals negative 1 plus or minus 3 square roots of 2. We'll have 2 answers for each of these. So the next one, x squared plus 2 equals 6. Still going to subtract 2. So we get x squared is equal to 4. I take the square root of both. This one is easy. X plus or minus 2, the perfect square. Then the last one here on the top, we need to get the squared part by itself, so we're going to add 3. So we have x plus 4 squared equals 25. When I take that square root, I get x plus 4. And the square root of 25 is plus or minus 5. So I'm going to subtract 4 from both sides. So x equals negative 4 plus or minus 5. Now, I want you to give me both of these answers. So negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. So when we have it whole numbers, give me both answers. So now I say you try. 2x squared minus 64 equals 0. So we need to get the squared part by itself. So I'm going to add the 64, so I have 2x squared is equal to 64. Now, we need to divide both sides by 2, because 2 is not something that's squared. So then I get x squared is equal to 32. So now I can take my square root. So this gives me x, and then 32, think about it, breaks down to 16 times 2. The square root of 16 is 4. So I'm going to have plus or minus 4 square roots of 2. And that's my answer. I'll do number 2 the same way. I'm going to divide by 2 first. So that gives me x squared is equal to 7. When I take that square root, I just get x equals plus or minus the square root of 7. Simple. And then number 3, we have a few more steps involved in 3. So first we need to add 18 to both sides to get the squared part by itself. X minus 4 squared equals 28. I'm going to take the square root of that. So I get x minus 4. And then 28 breaks down into 4 and 7. So I'm going to have plus or minus. Square root of 4 is 2. Square root of 7 I can't do anything with. And so then my last step, I'm going to add 4 to both sides. So 4 plus or minus 2 square roots of 7. And so there you go. That's using solving with square roots.